Hello everybody, this is Mr. Yen, and this is the video for lesson 7.6. And in this lesson, we are going to start looking at two-column proofs. So far, the proofs that we've been doing with congruent triangles, we've been using flowcharts, like the one you see on the left here. And then now we're going to start to transition from taking what we know in a flowchart and putting it into a two-column proofs. And two-column proofs are what you're going to be using a lot more in Math 2 and beyond. So you should have this worksheet in front of you, either open on your computer or printed out in front of you. And let's first read our given statement and what we're trying to prove. So the given information is that quadrilateral ABCD is a rhombus. That's A, B, C, D right here. And then we're being asked to prove that diagonal AC is an angle bisector. Let's first start by marking the congruences that we know from the given information. So if ABCD is a rhombus, remember that the definition of the rhombus is that all four sides are congruent. So we can mark that. So I know that this side is going to be congruence to this side, which is going to be congruence to this side and this side here. Okay, all four sides are congruent. And what we're being asked to prove is that the diagonal AC, so diagonal is the segment that goes from point A to point C, so that's here. And that it's an angle bisector. So remember, the definition of an angle bisector is a line that splits an angle into two equal parts, into two congruent measures. Let's take a look at this question here. And these two questions are to help guide your thinking to set up your proof. If AC is an angle bisector, what has to be true about angle DAC and angle BAC? So angle DAC, D to A to C, DAC, that's this angle right here. Okay, and then angle BAC, so B to A to C, that's this angle right here. We know from the definition of an angle bisector that if this line is in fact, if diagonal AC is in fact the angle bisector, then this angle, DAC, has to be congruent to this angle right here, which is BAC. So I can say that right here. If it's angle bisector, angle DAC has to be congruent to angle BAC. And so how can we use congruent triangles to prove this part in part A, that angle DAC is congruent to angle BAC? Well, notice that the diagonal splits the rhombus into two triangles. And we're trying to prove that this angle up here is congruent to this angle down here. And if we can prove that this top triangle is congruent to this bottom triangle, then we can conclude that these two angles have to be congruent. Okay. So how can we use congruent triangles? If we can prove that triangle ADC, that's the top triangle, is congruent to triangle. So if triangle ADC is congruent to triangle, the bottom triangle, which is ABC, then we can conclude that angle DAC is congruent to angle BAC. So now that we've answered these two questions, we know our goal and how we're going to get there. This is our goal, and this is how we're going to get there by proving those two triangles are congruent. Okay, I'm going to erase those markings so we don't get confused with our given information. And now, with what you've been doing the last two lessons, you should be able to put the information together and prove it all using a flowchart proof on the left. So what I actually want you to do now is I'm going to have you pause the video, and I want you to try to finish this flowchart proof on your own first. And then when you're done, resume the video and we'll check our work. So now you're pausing, complete the flowchart proof, go. At this point, you have paused, you've done as much of this flowchart proof as you can, and now we're checking back in to check your work. We're going to start by listing the given congruences that we have between these two triangles in our figure. Because it's a rhombus, we know that AD is going to be congruent to AB in the bottom triangle. I know that DC up here in the top triangle is going to be congruent to BC in the bottom triangle. I also have a third side that's being shared between the two. So I know that side AC in the top triangle is also going to be congruent to side AC in the bottom triangle because they share it. Okay, so from the given information, I have a side, and another side. So I can conclude that these triangles are congruent. So triangle ABC is congruent to triangle ADC. The top triangle is congruent to the bottom triangle because of the side, side, side criteria. Or three congruent sides. You can write either one or just side, 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 SSS for short. Now that we've proven that these two triangles are congruent, I can also list all of the remaining parts that are congruent. Well, if the three sides are congruent, then the three angles also need to be congruent. So this angle here is going to be congruent to this angle here. So I can say angle DAC is congruent to angle BAC. I have this top angle here is going to be congruent to this angle here. So I can say angle that's ADC is congruent to angle ABC. And last one, I know that this third angle here is going to be congruent to this third angle here. So that's angle, sorry, it's getting a little smushed here. Angle DCA, right? DCA is congruent to angle BCA. Okay, now we have our conclusion. For our conclusion, I'm going to go back to this original question here, right? Remember, if AC is an angle bisector, what has to be true about these two angles? So this was the main thing that we were trying to prove. So that's what I'm going to put into my conclusion. Therefore, angle DAC is congruent to angle BAC because, right, you always need to say why. Well, the reason why I know that these two angles are congruent is because we proved that the two triangles are congruent up here. And if the two triangles are congruent, then all their parts need to be congruent as well. And the math way of saying that is because the corresponding parts of congruent triangles are congruent. The corresponding parts of congruent triangles are congruent. Sorry for the glare. That's a little better. Okay, great. So that's our flowchart proof. Now we're going to take that information and put it into a two-column proof. The two-column proof is a little bit different, but it's getting at the same idea. Let's just look at all of the statements in this two-column proof. So first it's saying that these two sides are congruent. Those are the sides that we marked in blue. Then it's saying that AC is congruent to AC. Okay, so it's establishing that the three sides are congruent. That's the same thing that you did up here. Then it's saying that the two triangles are congruent. That's what you did right here in the middle. Then it's saying that then these two angles are congruent. That's what you did here. And then it's saying that the conclusion diagonal AC is an angle bisector. That's what we said down here. And now the only difference is we have to state the reason next to each statement for how we know that's true. So first, AD is congruent to AB, AD and AB, and DC and BC. So those are all the sides that I marked in blue here. Well, we know that those are congruent because they're sides of the rhombus, and all sides of a rhombus are congruent. So that can be my reason. I know that those sides are congruent because all sides in a rhombus are congruent. Next, AC is congruent to AC. Well, we know that that has to be true because they share that side, and any side is congruent to itself. And here we have some new vocabulary. This is called the reflexive property. In math, the reflexive property tells us that anything is always going to be equal to itself. 5 equals 5, 100 equals 100. That works with congruence too. Anything is always going to be congruent to itself. Side AC is congruent to side AC. Angle B is congruent to angle B. Reflexive property. Okay, next, after we've established that these three sides are congruent, then now we're saying that the triangles are congruent. And the reason why? Well, we said because of the side criteria, we can conclude that they're congruent. So I can write the same thing here. These two triangles are congruent because of the side. Sorry, that's a little messy. Try again. Side criteria. Then if the two triangles are congruent, I can conclude that these two angles between the two triangles are also congruent because the corresponding parts of congruent triangles are congruent. Now, for your two-column proofs, here's a little bit of a break for you. I'm going to let you write the acronym CPCTC. That's the acronym for corresponding parts of congruent triangles are congruent. It's the same thing, but since this is a lot to write, starting now, you are permitted to use this acronym. But you need to know what this means. Okay, and then the last thing, the last statement in your two-column proof is always going to be the thing that you were trying to prove. You were trying to prove that diagonal AC is an angle bisector. Why do we know it's an angle bisector? This is why we know it's an angle bisector. This is why we know it's an angle bisector, because those two angles are congruent. So the reason why we know it's an angle bisector, because angle DAC is congruent to angle BAC, right? It splits that angle into two equal parts. Okay, and so that is how you can take your information from the flowchart and put it into a two-column proof. You're going to try that now for problems 2 and problem 3. And with that, I'll say goodbye and good luck.